Examples in calculus, the product rule. This is video 3. Example 2 uses the product rule in the form y-x equals gx times f-x plus fx times g-x. The following list of 7 short videos shows all videos, including this one, that involve the product rule to find the derivative of a function in an example or an application. To review the above videos, you should pause this video now. All videos have been written and produced by Michael J. Bankhead. The product rule. This rule finds the derivative of a function that is the product of two separate functions. If a function y is defined as y equals fx times gx, then y is the product of two separate functions on the right-hand side of the equation, where fx is the first function and gx is the second function. Since y is the product of two separate functions, y-x, the derivative of y, must be found using the product rule. The form of the product rule used in this example is y-x equals gx times f-x plus fx times g-x. There are 4 separate functions on the right-hand side of the above equation: gx, f-x, fx, and g-x. Where f-x is the derivative of fx and g-x is the derivative of gx. Procedure. To obtain the derivative of a function that is the product of two separate functions, complete the following 4 steps. Step 1. Identify fx and gx on the right-hand side of the function you want to differentiate. Step 2. Find f-x from fx and g-x from gx. Step 3. Substitute gx, f-x, fx and g-x into the right-hand side of the product rule to find y-x. Step 4. It is usually necessary to simplify the right-hand side of y-x, and if y-x can be simplified, then it should be simplified. Note that simplifying can involve expanding, collecting like terms, factoring, or all 3. An example using the product rule. Find the derivative of the function y equals 3 into 2x plus 5 times e to the x. Solution. Reminder. In maths, the word expand means multiplying terms together to remove the brackets. Finding the derivative. Step 1. Identify f(x) and g(x). Comparing the right-hand side of the equation y equals 3 into 2x plus 5 times e to the x with the right-hand side of the equation y equals fx times gx gives fx equal to 3 into 2x plus 5. So after expanding, fx equals 6x because 3 times 2x is 6x, plus 15 because 3 times 5 is 15, and gx equals e to the x. Step 2. Find f(x) and g(x). Using the power rule, f(x) equals 6 plus 0 equals 6, and from a table of derivatives, g(x) equals e to the x. Note that the derivative of 15 is 0 because the derivative of any constant is 0. Step 3. Substitute gx, f(x), fx and g(x) into the product rule. From the previous screen, the product rule is as follows. y(x) equals gx times f(x) plus fx times g(x). So for this example, y(x) equals gx, which is e to the x, times f(x), which is 6, plus fx, which is 6x plus 15, times g(x), which is e to the x. Simplifying the derivative. Step 4. If the derivative can be simplified, then it should be simplified. From the last line of the previous screen, y(x) equals e to the x times 6 plus 6x plus 15 times e to the x equals, move the 6 in front of the e to the x, 6 e to the x plus 6x plus 15 e to the x equals 6 e to the x plus, expand the bracket, 6x times e to the x is 6x e to the x plus 15 times e to the x is 15 e to the x equals, collecting like terms, 6 e to the x plus 15 e to the x equals 21 e to the x equals 21 e to the x plus 6x e to the x equals, put the term with the highest exponent of x first and the second highest second. This will ensure that the exponents of x in the terms that form the polynomial in the answer descend from left to right. The exponent of x in the term 21 e to the x is 0 because 21 e to the x can be written as 21 times 1 times e to the x, which equals 21 x to the 0 e to the x after replacing 1 with x to the 0 because x to the 0 equals 1. The exponent of x in the term 6x e to the x is 1 because x equals x to the 1. Since 1 is the highest exponent, 6x e to the x goes first. And since 0 is the second highest exponent, 21 e to the x goes second. Equals, separate out 3 e to the x from each term. 3 e to the x times 2x plus 3 e to the x times 7 equals 3 e to the x into 2x plus 7 after factoring out 3 e to the x. Final statement. The derivative of the function y equals 3 into 2x plus 5 times e to the x is y dash x equals 3 e to the x into 2x plus 7. Reminder: the exponents of x in the terms 2x and 7 are 1 and 0 respectively. So the exponents of x in the polynomial 2x plus 7 do descend from left to right. When solving questions from your textbook similar to the example in this video, you should have the previous screen displayed so you can use it as a template to find the derivative, and this screen displayed so you can use it as a template to simplify the derivative. You should then find this topic simple and beautiful. Cheers! Do not forget to check your answers with the answers in the back of the textbook.